Welcome everybody. Today we will start our revision. We will start with Chapter 1, Lesson 3, Acceleration. For question number 1, define acceleration and write the equation for finding the acceleration of an object moving in a straight line. For the acceleration, we said that acceleration is the rate at which velocity changes. And we said that velocity is the speed in a given direction. So it means that if there is change in the speed or there is a change in the direction, both of them are considered as acceleration. And remember, we said that acceleration may be changing in speed or changing in direction. Changing in speed either by increasing or decreasing speed. In case of decreasing speed, it's called deceleration. So for the definition, acceleration is the rate at which velocity changes. What is the equation used to find acceleration? We said that acceleration equals final speed minus initial speed divided by time. And take care if the final speed is less than the initial speed, it means that the car is decelerating. So the value that we will have at last will be by negative sign. Okay, so again, for the equation, acceleration equals final speed minus initial speed divided by time. Question number 2, solve the following problems. A, velocity and time information for a rightward moving car are shown. Here he's given you the time, t and v. T is the time and v velocity or the speed by which the car is moving rightward. Right? So for the time, at the beginning at time 0, at last the time was 3 seconds. So it means that the time elapsed here equals 3 seconds. For the velocity, at the beginning it was 3 meters per second, and here it is 12 meters per second at last. So it means that the speed is increasing. Calculate acceleration and direction of the acceleration. As we said that the equation of acceleration is acceleration equals final speed minus initial speed divided by time. What is the final speed here? It is 12, right? And the initial speed is 3. So 12 minus 3 divided by time, which is 3, equals 3 meters per second square. And again, don't forget to write the units. For the direction, as we said here from the head of the question, it's written that the car is moving rightward. So the direction is rightward. Question B. How long will it take a car to go from a complete stop? Complete stop means that the speed or the velocity at this moment is 0. It's already stopped. To 44 km per hour if they are accelerating are at 5 km per hour square. Here he has given you the final speed, which is 0. The initial speed, which is 0, the final speed, which is 44, if they are accelerating at 5 km per hour square, and he's given you the acceleration. And in this question, he's asking you to find the time. As we said that acceleration, which is known, equals final speed minus initial speed, which are known too, divided by time, which is the unknown. How can I get the unknown, which is time? So you will divide final speed minus initial speed as a whole unit by acceleration. Equals, what is the final speed? 44. What is the initial speed? We said that it equals 0 because the car was going from a complete stop, right? So 44 minus 0 divided by time, which is divided by acceleration, which is 5, equals 8.8 hours. By this way you could find the time. And again, if you know the acceleration, the final speed and initial speed, you can find the time, which equals final speed minus initial speed divided by acceleration. For question number 3, answer the following questions. In science, what 3 changes can cause an object to accelerate? Again, we said that acceleration is dependent on the speed and the direction. So it means that it's dependent on increasing speed, decreasing speed, which is called deceleration, and changing direction. B. Read the following sentences and determine if it accelerates: positive acceleration or deceleration, which means negative acceleration, or no acceleration. 1. A rightward moving bicycle increases its speed from 2 meters per second to 12 meters per second. Here he has given you the direction, which is rightward, and he's given you the speed, initial speed and final speed, and he said that the speed is increasing. Is the bicycle accelerating? And what is the direction of the bicycle's acceleration? For sure the bicycle is accelerating as there is a change in the speed. The speed is increasing, so it means that yes, it accelerates. Which type of acceleration, positive or negative? Yes, it's positive acceleration because the speed is increasing. And what is the direction? It's rightward, as it is mentioned at the beginning of the question. Point 2. A bus is at rest. Is the bus accelerating? Here, the bus is not moving at all, so there is no acceleration. We said that acceleration is dependent on the speed and the direction, and it's already stopping, right? There is no change in the speed and no change in the direction, so there is no acceleration because there is no increasing speed or decreasing speed or even changing in direction. Question number 3. A car is slowing down. Is the car accelerating? Yes, slowing down means that the initial speed is higher than the final speed. There is changing in the speed. As there is changing in the speed or direction, so it means that yes, there is acceleration. But what kind of acceleration is it? Is it positive or negative? Negative, which is called deceleration. It's negative or deceleration. Why? Because the final speed is less than the initial speed, or the car is slowing down. Question number 4. A downward moving elevator is speeding up. Speeding up. Is the elevator accelerating? And what is the direction of the elevator's acceleration? He said here in the question that the elevator is speeding up, so it means that there is change in the speed, right? So there is acceleration. What kind of acceleration? Positive or negative? Positive. Why? Because it's speeding up. If the object is speeding up, there is positive acceleration. If it's slowing down, there is negative acceleration. What is the direction? It's mentioned here, downward moving, so the direction is downward.